Great. Well, thank you very much. I'm delighted to be here, and especially to be after my colleague Janos, who, with all the team at NextFlex are doing great things, and it's fortunate that they have a funded research project which many of us across the U.S. and elsewhere are able to engage with. Today, I'd like to talk to you about the fabrication of multi-sensor vital sign patches for ambulatory care. We all think of, medicine as being probably the first thing when we think of a wearable. Here at Binghamton, we're also thinking about the wearable for industrial applications as well, but we'll save that for another time. Aside from the abstract, I clearly want to acknowledge my colleagues, Azar Elizadeh and Andrew Burns, in particular at GE. The funding we received from NextFlex, from the SEMI organizations, especially the NBMC, and the cost share that we received from New York State, Empire State Development. And I'll also acknowledge the significant role of TapeCon, a New York State manufacturer who's starting to manufacture in this area. So as Janos has told you, flexible hybrid electronics is using additive approaches to print those circuits and interconnects, and not trying to pretend we can print semiconductor devices other than some sensors, but make use of the best that comes from the fabs and find a way to remove the semiconductor device from the molding compound that protects it and its interconnects, to make it thin, like American Semiconductor does, very thin and supported on plastic, and then be able to print the interconnects directly from the substrate to those devices. And ultimately, this not only gives us a thin device, but as Janos has indicated, NextFlex is working on that next level of the edge computing realm, where the processors and the communication devices will also be thin and light like the sensors themselves, helping us to have a more integrated system. Here at Binghamton, we've had many projects working with this group, looking at every aspect, whether it's printing antennas, filling vias, attaching die, printing resistors, capacitors, inductors, RF solutions are low-hanging fruit in particular, and looking at placing components, and all that looking on a variety of substrates, which could be multi-layer, could be two-sided or just single-sided. And of course, the need to fill those vias and to make connections from layer to layer or from top to back is key. Our group also has the capability to handle everything from design and simulation through fabrication and reliability and performance tests. And so in these, with every application we engage with our company partners, we look at applying these skills and applying this increasing level of knowledge to achieve the next set of results. Core to everything we do is printing. And quite often with specialty devices, we're looking at Optimec and aerosol jet printing as ways to work with specialty materials, whether it's gold or platinum, of course, silver, carbon nanotubes, printing wire bond replacements, printing dielectrics, printing photoresist, you name it. You can do it with a tool like this. And of course, as also Janos indicated, you can print on surfaces and start to address this long need of reducing weight in things like drones and other things, where why add circuit boards when you can print those electronics on available surfaces? And that's all possible with some of these methods. Today's talk will stick to a little simpler realm and focus on things that can be either dispensed or screen printed. In particular, we'll look at the need to make multi-layer lead sets. These are multiple screen printed passes with different materials. In middle is a silver conductor, typically, but much the need to replace a coax cable, which allows low amplitude signals such as critical vital signs and ECG patterns to get through from the body into electronics, and when worn, pass various layers of clothing that might cause triboelectric noise. And so together with our team, working with GE and many other colleagues, we've looked at least three major thrusts: sweat and hydration, currently working on interstitial fluid and the ability to diagnose through drops of fluid obtained from just below the skin. But today's focus is looking at this vital sign patch. And really the motivation is when there is a need to transport or to monitor large numbers of individuals, really the only way to do this is to have ability to collect high-grade medical data and alert maybe those few attending